Space Chronicles, in partnership with the European Space Agency.
Water, water everywhere. A vital resource that's a defining feature of our planet. But how much do we really understand about the water around us? Where does the water on Earth come from? Where do you find water in space? And what role does it play?
In the universe, we have discovered that, again, water is present a little bit everywhere. And water is the molecule associated with the process of life, as you know. So this doesn't mean that whenever we find water, there is life there. But understanding better its role and how common it is as a molecule, quote, its support of life is, I think, kind of a crucial question.
Time for a lazy Saturday afternoon outing on the River Thames, just west of London, for the Mandolin, what's known as a gentleman's weekend cruiser. When she was built back in 1932, space travel was still a distant dream. 76 years later, and researchers like Giovanna Tinetti are using space telescopes to look deep into the universe. Last year, Tinetti found water vapor on a planet outside our solar system for the first time. An important discovery, even though the planet is far too hot to be able to support life.
Water has a fundamental role in terms of understanding the chemistry of a particular environment. So for planets, certainly, knowing that there is water in that particular environment, it means that probably we should expect a type of chemistry that will not be present if water were absent. So it's in a certain sense an indicator of what's going on in terms of planetary science.
We sometimes call Earth the blue planet. Look down from space and you can see plenty of water. We believe most of it came from comets and asteroids hitting the surface soon after the planet's formation. Evina van Dishog is an expert on the role of water in the process of star formation.
Some of those molecules, or in fact many of those molecules, are probably more than 4 billion years old. And they have, of course, been recycled. They have evaporated and condensed back again. They have gone through the whole water cycle on Earth. But a lot of the original water, we know, is still here.
It is still here, and it's still carrying a clue about where it came from.
Not all the water molecules that we see here in this river are identical. Most of them have 2 hydrogens and 1 oxygen atom. But about 1 in 7,000 molecules has a somewhat heavier hydrogen atom, which we call deuterium. And we do call that water, we call actually heavy water. We see that actually also in material in comets. Comets are also enhanced in heavy hydrogen. They also have a large amount of heavy water. So this is one of the questions. Can we trace sort of the origin of the water on Earth through the fraction of the heavy water that we see in the various objects from which we think the water comes, like the asteroids, like the comets?
So it may be possible to trace part of the Earth's history back to the time when our star was formed by looking at something as seemingly simple as water. In order to understand the process better, we can study areas of the universe where other stars and planets are in the process of being born.
One thing that is very peculiar of water, and in a certain sense we are very lucky since we are so interested to search for this molecule, is that it has a very peculiar, very distinctive signature that spectroscopically speaking, because usually that's the way actually we search for water in the universe or in different planets. And it's going from the visible part of the spectrum up to the far infrared and even over. So in a certain sense it's relatively easy to look for it because of this very distinctive and very strong spectroscopic signature.
Space telescopes are used to track that special signature. One of the pioneers was the European Space Agency's Infrared Space Observatory, which operated in the mid-1990s. ISO found water was abundant in our galaxy. The Herschel Space Observatory, which is due for launch within a year, will also be used to study the role of water.
Water in general is extremely difficult to observe from the ground because of the water vapor in our atmosphere. And this is why going into space makes all the difference.
It's a tense time for Albrecht Poglich as Herschel prepares for launch. At his labs at Garching in Germany, the flight spare of his instrument is being put together. He has high hopes for Herschel.
It's a big step ahead just by the size of the telescope. I mean, previous space missions had a telescope size of a maximum of 85 centimeters. Now we are flying a 3.6 meter mirror. What we were able to do before at these long wavelengths was like the resolution you have with your bare eye when you look into the sky. And now it's looking like looking through binoculars. That's a big difference.
Herschel's powerful instruments will help Evina van Dishoek explore the theory that water vapor serves as a kind of heat radiator in regions of space where clouds of gas and dust are forming a new star.
Regions of space between the stars are not empty, but they are filled with a very, very dilute gas. And the denser concentrations of that gas are called interstellar clouds. These clouds consist mostly of gas, mostly hydrogen, and also tiny dust particles. Water is an important coolant of the clouds in which stars are formed, and in fact it enables clouds to collapse to form new stars.
Whether it's ice, vapor, or liquid here on the Thames, water appears to be one of the most abundant and important molecules in the universe, a key piece in the cosmic puzzle.
This type of researches on long term can actually bring us a lot of information to understand better our own planet, because finally that's probably the most important issue. How we were formed, how we evolved, and where we will go in the end.